This is related to T distribution, a family of probability distribution that can be used to make inference about population mean. Whenever the parent population is normal and the simple standard deviation is used as an estimate of the population standard deviation. The T distribution is characterized by the degree of freedom which is 1 less than the number of observations. So like the standard normal distribution, it has the mean at 0, but the standard deviation depends on the degree of freedom. The T distribution is also characterized by the symmetric bell-shaped curve, but is more spread than a standard normal distribution. So here is the distribution, and you see the mean is 0, and the degree of freedom is depend upon the shape of this shape. So if the degree of freedom is increased, so the shape is like this one. So now we start our example and import the data. The data is length. The data is 44 students and 69 students, which guesses the average mean of the width of room. So 44 students are in meters, guess in meters, and 69 students guess in feet. So first import the data. So here is our data. Now we change the name of the column. So first column is unit, and the other column is length. So this is our data. 113 rows. F is feed, measurement in feet, and M is for meter. So because we have two type of categories of measurement, so we just convert the meter into feet. So we use one more column to do this. So for adding the column, use a query builder. New computed column, advanced expression, build an advanced expression. So case is when unit m a meter, then length is length multiplied by 3.28. So, and when unit is equal to feet, then length is equal to same. So we convert all meters into feet. Next, this is a column name. Run the queries. Now we convert all meters into feet, and feet are also same. Now we drive a summary statistics. Now summary statistics, in that we find out the basic measurement of statistics. So just close it and go to task, describe, distribution analysis. Now see, we analyze the analyze variable feed. So our analysis variable is feed. Just drag and drop, and unit is a classification variable. Now go to the table, and we need only the basic measure. So remove the checkout and run this query. The yellow icon shows that this is still running, and here is the task. Auto finish is loading. Now here is the conclusion that the unit is feed, and our mean is around 43. So this is around same as our answer. But now here, if we see the measurement of unit m meter is 52, this means that this is too far for our mean. So here is we can conclude the some basic measurement, basic statistics measure. Now we're going to draw the box plot. Box plot is, select this one, task, graph, and box plot. Take the sample, box plot, click on data. Now we take a unit into a unit into a horizontal axis and feed in vertical axis. Check some properties. Now run the box plot. See the status, and then it's loading the box plot. Now here is the box plot. Uh, as we mentioned, the unit is on horizontal axis and feed is on vertical axis. So in this box there is a mean here, and the important thing is some outliers. So if we see in meter measurement, here are our outliers. So we consider this one is that the is the outlier or is some mistakes. So when the data comes to ours, and we can check through these outliers. Now we move to the another graph is called a histogram. Just like this one. Task, capabilities, and histogram. Same as analysis variable is feed, and classification variable is unit. Different options. So here is our classification variable limits are 2, so 1, and also we just put. Now here, inferential statistics, a branch of statistics that is concerned with the development and applications of methods and techniques for drawing inference about the population on the basis of observation obtained from the random sample, usually with a certain degree of uncertainty associated with it. And also the definition of statistics test, the statistical procedure of any of several tests of statistical significance used to test a null hypothesis. The test assesses the compatibility of the experimental data with the null hypothesis. The procedure projects the null hypothesis if an observation difference, one or more extreme one, would have a small probability if the null hypothesis were true. Some example of statistical tests are t-test, C2 and f-test. So now we just see the p-value. P-value, the probability of obtaining a difference between the value of the test statistics and the hypothesis with the parameter that is greater than or equal to the difference actually observed. It is the probability of observing a result as extreme as or more extreme than actually observed from the chance alone, assuming of course that is the null hypothesis true. If the p-level is less than the level of significance for the test, the null hypothesis should be rejected. So now we go to our test. First we go to here to filter the data, because here are we use the column feed, and if we analyze the data, we just segregate the data of meters and feet. So filter data and filter the data, which one, the unit, equal to select meter. Okay, now we get the data of meters. All are meters. So here is the length is in actually meters, and the unit is meters. So now we just test our hypothesis. Remember, the length is in meter and the feet is actually the in length in measure in feet. So now we go to the analyze. Now we go to the task, ANOVA and t-test. Task, ANOVA and t-test. We select one sample and now data is analysis variable is the analysis variable in length, which is actually the meters. Go to the analysis, select the null hypothesis is 13.1. Go to the title, use the title as test with HO null hypothesis is 13.1. Now click run. Now we get the data with a t-test procedure and our null hypothesis 13.1. So here is the mean, like here is the mean, which is for our 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 data. So here is we can find the uh, t-test. Now if we want to see the t-test for two classification variables, so here is the same is task, ANOVA, t-test. Now we take the two samples. Now we change the data, analyze data. So analyze variable is feed, because this include all of the meter and feed data. And the unit is also classification data. Now we run this again. Here we see we get the all E values is here with the 95 confidence interval, and also the mean is here. So in this method we can find the t-test over. Now let's take another example. I'll import the data. Here is waves.tab. That's the tab file, and first I import the data and then I'll tell you what is the data. I give the example of rename of the column. Just go back here, and first is the pair number. Okay, first is the pair number. For second is RSMB1 and RSMB2. Next, so here is the pair number, and RSMB1. This is RSMB2. I just change the label. It's EAIR pair number, and this one is method 1. This is method 2. Method number 2. Now here is our data. So what is the data? The data RSMB is the method 1 and RSMB is the method 2. As we can tell you, there is a two moving method for in electricity generator. There is in C, and this one is the method 2 for the method 2 to generate the electricity, and same as the method number 1 and 2 are the different types. So we want to find is there any difference between 1 and 2 methods. So let's now we just analyze that one. So first we find the difference between RSMB1 and RSMB2. So go to the query builder, computed column, advanced expression, same thing. Now we just type the difference. We also can select here from RSMB1 minus RSMB2. Okay, next We change this one. That's a difference. Next, and this is finished. Run this query. Now we get the third column, which is the difference between RSMB1 and RSMB2. Now we can see we are going to the box plot for that one. So how can we plot the box plot? So first go to the task, describe describe distribution analysis. And we can RSMB1 analysis variable, RSMB2 and difference. Now we go to the plot. Appearance, and here is the box plot. So remember, plot, appearance, box plot. Plots, appearance, box plot in distribution analysis. Now run the queries. Here is method 1, method 2, and this is the difference. So now here is the box plots of difference. This figure, there is a one observation here. This is outlier. So we may check to how is that the outliers, or this is the error in the data or something happened. So we will check through through the other methods. Pair t-test. So to see is there any difference between both of means, because we use the t-test in to see the mean, population mean. So now here is we use a pair t-test because here are two means and two cases. So we see we'll see the two means, is there any difference between two means, and also the p-values. So we analyze the data, select the data, and we see the data and analyze task, analyze task, ANOVA, task, ANOVA and t-test. Task, ANOVA, t-test. We select the pair t-test. Go to the tab menu. assign one variable is RSMB1 and RSMB2. So we have the two variables. Now run the process. So we got the result, and here is the shows that the p-value is 0.3797 and the means are 0.0671 and 0.2 0.259 0.259. So you can see the two means are the same. So there is let's double check the queries. Modify t-test. That value. Okay. Yes, that's right. Analysis, plot. So all is okay. So here is the result and the value. Now we analyze one more the same data with one more test that's called a wilcoxon signed rank test, and we do not use the normal probability plot for because the data is small. Now we go select this one, go to the task and same distribution analysis, data, and the difference is the as an analysis variable. Select the tables and here is the test for locations. So deselect the all. By default there are three selection, so we just remove two selection, only the test of location we select only that one. So now we run the queries, this one. So again p value is 0.37194 is proof that there is no difference found in the all moving methods. Alright, now here is our process flow. We just import the data. Here is the data SAS data set. Build a query to generate a column difference, and this is the new data set. And is this new data set will have 3 columns, and we analyze the distribution analysis with the different box plot, t-test, and also wilcoxon test. So regarding three analysis, we say that there in that data set there is no evidence found with in the moving method.